Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we're going to look at collections, which are like full-powered arrays. We're also going to look at object and collection initializers, which are nice compact ways to set some initial data in your objects and your collections. Get to that in just a moment. Now, previously, when we looked at arrays, we said that an array is simply a sequence of data that's stored in memory, and you can access any individual element of that sequence by using its index, or in other words, its ordinal value or position within that sequence. And arrays are great, but they lack a certain number of features. For example, the length of arrays are fixed once you declare them. But what if I need to add more items to the array? Or what if I need to remove items from the array? Or what if I don't want to use an index, an ordinal position in the sequence, but I'd like to use something a little bit more friendly. Like, for example, if I was working with customer objects, maybe I want to use the last name of a customer to look them up within my array or my sequence of customer objects. So what I want to do is demonstrate the use of collections, and I created a setup project. So if you go to wherever you downloaded the code for this particular video, should be something like C9CS21, and go into the before folder and copy and then paste in your projects directory for the Visual Studio 2010 projects directory. Just paste that in there. And then open it up and double click on the solution file. It should say, Visual Studio Solution off to the right hand side. I'm going to double click that and open it up within Visual C#, Express Edition, or in Visual Studio. And what I want to do is start off with some code that I've already worked with and created just to demonstrate the old style of collections. Now, you can see I've set up collections here by creating a car class and a book class. Very simple, just with some public strings. And then I created instances of cars and books here within my static void main. Now, I'm going to paste in this first chunk of code, which allows me to work with a type of collection called array list. And there might be, I don't know, a dozen, maybe 24 different types of collections that we can choose. Each collection is geared towards a certain type of functionality that we can expect. An array list is a very simple version of a collection. And again, I just want to get our feet wet, so I wanted to choose something fairly simple. It behaves sort of like an array, except with some extra features added to it. So you can see I created a system.collections.arraylist called myArrayList, and I initialize it to a new instance of that class. Now I use the add method to begin adding individual objects that I've already created instances of here a little bit higher up in my application. Now notice something that's a little bit weird about this whole thing here, and this will come back as we continue our discussion. Notice that the add method accepts any type of object. When you see that word object, that really means system.object. If you'll recall from our discussion of inheritance, all objects in the .NET Framework class library, all types, everything derives from a single base class called system.object. And so you can put essentially anything you want to inside of this array list collection. In this case, I'm putting cars, but I could just as easily put a book as well. And that's kind of neat. There are some downsides to that. The first downside is that if you store everything in it as an object, then once it comes out, it will be an object. So there will be some conversion that happens. And when you bring it back out, you're going to have to cast it back to its original data type. So you can see what I've done here. In the for each statement, I'm for each object O in my array list. And so as I get the current item in the array list, I'm casting it to car, and then using a series of open and close parentheses, getting at the make property defined in my car class. And so if we ran the application, it will start off just fine, but then it's going to hit a little bump in the road, so to speak. And that is because we get to the book object, which is the object of type book. We try to cast it to car, but it gives us an exception that says we can't cast that object to a car because it's fundamentally a book. And so therein lies the first challenge with our array list, and as that we're working with loosely typed objects, not strongly typed objects. Okay. However, there are some neat things about the array list as well. For example, I can go remove. So I can remove an item. Now let's see, once we've removed that book, and try to loop through it if our example will work. And it seems to work just fine. Okay, so we can change the size of our array list by adding and removing items. It's not fixed like an array would be. Okay? And there are some other cool features too. If we were to just look at the IntelliSense, there are things like the ability to reverse sort, get a count of items, and so forth, that are maybe available at least in some degree in an array, but not as fully featured as with our array list. But let's move on, because I have another type of collection I want to demonstrate, and that is a dictionary. So let me copy and paste some code that I wrote earlier. And the key here is not for you to type out this code. That's why I'm just pasting it in, because I don't want you to use these old style collections. There's a new style collections that's going to fix some of the deficiencies of these original collections that were added way back in like 2002 in the original .NET framework. We're on version 4 or beyond when you're watching this video. Okay, so at any rate, you can see we have another type of collection called a list dictionary. And dictionaries are known because they have both a key and the actual value that you want to store. And the key allows you to easily look up the associated value in the dictionary. Okay, and so we have system.collections.specialize.list dictionary. My dictionary equals new system.collections.specialize.list dictionary. So you can see what we're doing here with my dictionary.add. This time we're giving it a key, and for my purposes, I'm just going to use the make of the car as the key. It needs to be unique, so if I try to add two cars with the same make, I'm going to get an exception. Furthermore, then I'm adding the actual item itself. Now, we are going to suffer from the same issue that we had before. Notice that both that key and value both are of type object, which means we're going to be working with loosely typed data, which will give us the possibility of making a mistake like this one here, where we're trying to add a different type of key. Instead of make, we have to use author because we're dealing with a book. And then we're sending in a different type, book, instead of car. Now, the dictionary will allow us to do that. The problem is not when we're adding it or removing it. It's when we are trying to work with iteratively. We're expecting to work with one data type, but perhaps some other developer who wasn't aware of how we were storing the data internally may have inserted a different type in. So in that case, our application would behave similarly to what we saw in the array list. The other issue is that since we're dealing with a type object, and I can use any type of key, we run into a situation where I could put any type of value here in what I've been referring to as magic strings. So if I were to run this application, this first line of code will function the way we would expect it to. You can see we get at a single instance of car stored in my dictionary by using its key, geo, which if we look up here, we can see it'll find car2 using that. Once we use a number of parentheses in order to get at the casted object's property, then it'll print it out to screen. But the problem comes in is if we give it a key that doesn't exist, if we run the application, we're going to get an exception. Unable to cast object of type collections.book to collections.car. Okay, so it did find an object since we're using author, but it's unable to cast it again. So we're running into the same issue that we ran into before. Okay. Now I said all of that to say this. Let me comment this out. What if we could create a collection that was specific to either book or car? Then we could only add instances of the correct type into the collection, and we could also treat all items in the collection as a given type, and we wouldn't have to do that whole casting thing like we've done here with a bunch of parentheses in the car and potentially run into issues there. And that's exactly what happened several years ago in C# 2.0. Microsoft added a new set of generic collections to the .NET Framework class library. The concept of generics is a bit advanced, but in a nutshell, if I had to greatly simplify it, I would say a generic type provides a basic implementation of some functionality, like a collection, for example. However, you, the developer, the user of the generic collection, you make it specific by adding your own data type to it. So I can make a collection only of type car. I can make a collection only of type book. I get to make it specific by telling it what type it should be working with. Okay? From that point on, that collection is strongly typed, the type that you defined it to be. And you define the specific data type by defining it between two angle brackets. So let's do this. Below this section of code that I commented out, I'm going to go use a new generic collection. Now, notice that I'm able to get IntelliSense and everything. Why is that? Because by default, Microsoft saw that it was so important to have this namespace added to your project that it adds it automatically to all project types. Okay, so it is in system.collections, like we saw earlier, and then they added on an additional namespace called generic. And so now we can get at all of the generic collections easily. So list of type car, my list equals new list of type car. Okay, the angle brackets, the type that's in between the angle brackets is the specific type we want this generic collection to be able to accept and work with. So we can do this, watch. So my list.add car. Now notice in the IntelliSense, it doesn't take a type of object. It takes only type car. So I can do car1, my list.add car2. Now watch what happens as I try to add the book B1, and I'll hit. Now notice that we get a red squiggly line. If I hover my mouse cursor over it, it says that the best overloaded method for system collections generic list of collections.car add collections car has some invalid arguments. Why is it invalid? Because the type is incorrect. I cannot add a book to my generic collection of type car. Now, watch what other neat thing I'm able to do. Since I'm only working with cars, I don't have to do any casting. Whoops. And let's run the application. All right. So you see how much more simplified this code is than some of this earlier code where we had to use a lot of parentheses, casting, and all that business. All right, it makes it a lot easier. So that is a list. Let's do the same thing now, but with a dictionary instead. And the dictionary is a bit different because notice that it takes, we have to supply it with two data types. A data type for the key, so we'll make it a string, and then a data type for the value, and we'll make that a car. So type of string, type of car. Whoops, there we go. My dictionary equals new dictionary string car. Awesome. All right, so now let's do this, add, and I'll do car1.make, and then car1, my dictionary.add car1 or car2.make car2. And so I can do something as easy as this. Console.writeLine, my dictionary and let's run our application. Okay, so we're able to easily get at a single item in our dictionary without any casting or anything of that nature. Okay, so again, generics are simply data types that are waiting for you, the developer, to make them specific by supplying a data type between the angle brackets. So take a look at another form of generics that we saw previously. Let me save the work that we've done so far. Actually, let me open up a second instance of Visual C# Express Edition. And let's take a look at the Using Enumerations project from the previous lesson. Now notice here, the try parse had an open angle bracket and a closed angle bracket, and between that we used the data type superhero, which was an enumeration of the superheroes that we had in our project. What did this do? Well, it made try parse specific to superheroes. So when we got my value back out of the try parse, we send in a string, we're going to get out a value of type superhero. So it makes it's generic until we give it a specific data type. And from that point on, we're working with a specific data type. Okay? Hopefully that makes sense now. So let's continue on, move on to the next half of this lesson. I'm going to comment all this out. All right. Did you remember when we worked with arrays, we did something like this? We were able to, in one line of code, initialize an array of strings called names, and we initialized the values to strings, literal strings, by just specifying them between an open and closed curly brace. And you might recall at that time, I said that you're going to see this pattern again when working with collections. And so as you look at examples out there on the internet and on MSDN, you'll see the use of object initializers. And we'll start there and then we'll move to collection initializers in just a moment. So it really just does the same sort of thing. It allows you to shorten several lines of code into a single line of code. So previously in our examples, we did something like this. Car1, where then we set on a separate line of code, we set the make equal to Oldsmobile and the model equal to Cutlass Supreme. Well, let's go down here. Maybe we should comment some of this out too, so I don't step over myself. All right, so we're gonna get rid of all that. Come down here. Now watch the use of object initializers to do essentially the same thing. Car1 equals new car. Now notice when I hit the spacebar on my keyboard, it shows me all of the public properties that are available for the car type, the car class. So I can simply set make equal to Oldsmobile, model equal to Cutlass Supreme, car2 equals new car, make equals geo, model equals prism, and we'll even go for it, car, since it's so fun to type this. Make equals Nissan, model equals Altima. Great. All right, so the syntax is easy. After you create a new instance of the class, you use an open curly brace, and then inside the curly brace you can start by setting properties in a property name equals and then the value. And I just happen to be using strings here, but this will work for any data type. All right, and then you separate them through the use of a comma, and you have to make sure to close the whole thing at the very end. And now you have 3 objects initialized and ready to be used in 3 lines of code. Pretty cool. All right, so now what I want to do is really cook your noodle, and I'm going to comment all this out, and I'm going to show you how to create collection initializers. Now again, I'm doing this because I want you to be aware of this code. You're going to see this syntax in code examples, and if you're not aware of this and what it's doing, then you might get a little bit lost. So just simplify it and understand that you can use the same sort of syntax by initializing new objects with the initializer syntax within a context of a collection. So watch this. So we're going to create a new instance of a list of type car, new list of car. Now I'm going to open and close some curly braces here, and between that I'm going to type in new car. Whoops. Okay, so even though it looks like it's about 4 or 5 lines of code, that's really only 1 line of code, frankly. Once you wrap your head around object initializers, then collection initializers really are easy. So I formatted this code by breaking it up into several lines, but again, it's technically just one statement. So after the declaration and the creation of our new instance of the list of type car, then there's an opening and closing curly brace. And then inside we create 3 new instances of car. Now notice that I didn't create an identifier to hold the new instance, such as car1, car2, and car3, like I did here, or like I did at the very top here. But what happens is ultimately the same. We're only creating, whenever we do this syntax, all we're really doing is creating a new instance in memory and then getting a reference and then holding on to that reference using that variable name. Well, I'm essentially creating new instances of car and then adding them to the collection. The collection will keep track of the reference to that position in memory that holds that new car. So as long as somebody's holding on to it, that's all we care about, right? Okay. And again, this syntax may look a little bit daunting at first, but you'll see it so often in code examples that I want you to be aware of it. You should familiarize yourself with it and use it from the beginning of your experience with C# so that it becomes part of your personal preference. Okay, so let's recap. We started off by looking at collections as a robust alternative to arrays. But as we started using the basic collections available in the system.collections namespace, we saw that they weren't strongly typed, and therefore we just quickly discovered some downsides and some challenges to using the original collection. So I said, hey, wouldn't it be great if we could create a collection that was specific to car or book? And that was the impetus behind creating generic collections, or rather a generic implementation of a collection that's made to be specific by you, the developer, by giving it a data type inside of the angle brackets whenever creating a new instance of the collection. That's a generic collection, or what a generic collection does, or a generic method does, as we saw in our enumerations project. It allows you to define the specific data type for that implementation. Now we could work with collections in a strongly typed manner, and we saw how grave an improvement this was, frankly. We moved on from there and we started talking about object initializers, and then once we got that under our belt, we moved on to collection initializer syntax as a shorthand method to creating instances of objects within a new instance of a generic collection. Alright, so we're getting close to the end. In the next lesson we'll use a relatively new syntax called link, L-I-N-Q, to query data from our generic collections. We'll see you then. Thank you.